After you lock and shim the experiment, you're going to move to the Acquire tab and click Default H1. And this is where we're going to set the width of the sample. If you don't know what your sample is, or you're trying to see what you made, you want to keep the sample wide for the experiment. So we're going to keep it between -2 and 14 ppm, so it's going to be a width of 16 ppm. We do know what we have and we made our predictions, but just in case there's any impurities in the sample, we're going to keep it wide. In addition, the number of scans for the proton NMR is going to be 8. This is how long it takes. The proton is relatively fast for the scan, so leaving it at 8 is okay. But for like any carbon or any longer proton NMRs, you might want to decrease that depending on how long you want to run it for. And then for the acquisition time, or also known as like block size, this is how frequently to transfer data. Since the proton doesn't take too long, we're going to set it to 32, and this is, but again, if you're running a longer sample, you're going to want to decrease that. So just to recap, the settings for the 1D proton spectra, the width of the spectra is going to be 16 ppm from -2 to 14. The number of scans, we're going to do 8, and the block size is 32. The settings for the G-Cozy are a little different, but we're going to stick with the same idea. We're going to keep the spectral width wide, so we're going to keep it at 6,402 hertz. This is a 2D spectra, so it's in hertz instead of ppm. For the acquisition time, we're going to keep it at 0.150 seconds. This is a relatively longer experiment to run. It's going to take about an hour to run it versus 20 seconds for the proton NMR. And then finally for the scans, we're going to run it at 24. The first thing we're going to do once we acquire Spectra is we're going to integrate the signals. First, we're going to do this by zooming in on our spectral peaks to get a better look at them. So at the top right legend, there is 2 bars, and you're going to have the 2 bars show up. You're going to left click on the left side of the spectrum, right click on the right side of the spectrum, and then hit the zoom bar to zoom in. Next, you're going to cut the areas you're going to integrate. So on the right side, the 6 bar down is the integration tab. You're going to select it, and then you're going to left click and right click over the spectrum towards the bottom of the lines. You only want to select the peaks that you want to integrate. Once you left click and right click over the entire spectrum, you're going to select one of the peaks where you know how many protons are supposed to be there, and you're going to use that as your standard integration area. How I do this is every proton is equal to 100 integration area. So if you have 1 proton, you set it equivalent to 100. I'm going to set the farthest peak on the right equivalent to 300 because there are 3 protons that are supposed to be there. Once I set that on the right bar, I'm going to hit show integration, and then the integral values will show up on the bottom of the spectra. The last thing you're going to do for the proton NMR is lower the bar back down over all the signals you have integrated, and then you're going to show the chemical shifts, and they'll show up over the graph so you know where each peak is. Now when you click auto plot preview, you'll have all the integral values and the chemical shifts for every peak in your spectra. For analyzing the G-Cozy, you're going to select the box at the top right corner, and you're going to create a box around the area of the cozy that you want to zoom in on. Once you make the box, you're going to click the zoom button and zoom in, and then click plot preview, and then you have your analyzed zoomed in cozy spectrum. 3 things that indicate a high quality usable spectrum. One is that there's limited noise. For the proton NMR, that means on the baseline it is relatively flat, and for the cozy there's not a lot of random peaks around the spectrum. 2, the peaks with distinct splitting, and there's no interference by different contaminations or a poor shim and lock signal. And 3rd, there's no contamination of the sample by water or other solvents, and if there are, you usually have to rotovap. You have to purify the sample more to get a better NMR experiment run.